Hello, everyone. I see the first people are starting to join in. Hello, welcome. This is the webinar dedicated to KAUST University, Study Science and Technology by the Red Sea. My name is Lavinia, and I'm part of the Docsity team. It is very nice to be here with you all, and I am glad to be able to introduce you to this amazing university. Here tonight with us are Rosemary Ann Mills. She will give us a brief introduction about KAUST and the CEMSE programs. Then we have Carlambos Constantinou. He will speak about cybersecurity and resilient computing at KAUST. We have Nazek Elatab. She is involved in the electrical and computer engineering department, so she will speak about opportunities related to that. Then we have Maurilio Matracha, and he's a student in ECE at KAUST. So it is very nice to have you here with us tonight. I encourage you all to drop your questions related to the programs in the Q&A box. You can, of course, ask them as we go, and if you see anything of interest for your background, just please ask the questions, and the speakers will ask them as we go and also at the end of this webinar. So thank you again for joining us, and I will now leave the floor to Rosemary. Thank you.
Is my screen on show, or?
Yes, you can see it. Thank you.
Wonderful. Okay, thank you very much, Lavinia, for the introductions, and thank you so much for everybody for coming online and joining us here today. I'm really thrilled to have the opportunity to speak to you about KAUST and the CEMSE division. It will take me about 10 minutes just to give you a broad overview of the university, and then we will move on to get into some more in-depth conversations about some opportunities within the scientific fields that we have here. So my name is Rosemary, and I'm the student recruitment specialist for the CEMSE division. And I'm not originally from Saudi Arabia. Like a lot of people at KAUST, I'm an expatriate, and I originally come from the UK, and I like to play golf, I like to go diving, I like to cycle and use my bicycle. And if there's one thing that you can take away from this presentation, it's that KAUST is an enabling place which is full of opportunities. Of course, opportunities for science and research, technology, but also in terms of your lifestyle and the kind of things that you can do here. So KAUST is a graduate university located by the Red Sea. It was a dream that was born from the late King Abdullah, and many, many years ago, Saudi Arabia was the home of science and technology, and he wanted to reintroduce a house of wisdom at KAUST. And the university is located around 1 hour north of Jeddah. And Jeddah is just like any other international city. It has some historical points of interest, but it also has modern shops, malls, and good restaurants that you can enjoy. And KAUST is very unique because it combines this cultural heritage along with lots of modern facilities. So, for example, on the campus, we have a supercomputer located physically on the university campus, which our students and our interns can get access to for their research if they want to. So I'd like to just show you a very quick video about KAUST, and then we can continue to talk a little bit more. So I hope that from that video you can understand that KAUST is more than just a university. We're actually more like a small city or a small town. Every student that is admitted to KAUST, whether you come on an internship or as a full-time student, is allocated student housing in a shared unit with one other person normally. And around the campus, you'll find things like a golf course, you'll find swimming pools, recreation facilities. There are free buses that can take you all around the campus. And there are also lots of restaurants and things, names that you would recognize. So it's really a very familiar environment here in KAUST. And KAUST is an international university, so we have over 120 nationalities represented on the campus, and we're a merit-based university. So this means that we consider applicants based on a number of different factors, things like GPA, references, personal statements, previous research experience, and I'll explain a little bit about the admissions criteria later on in the slides. So we are a graduate university. We only offer master's and PhD degrees. The only undergraduates that we have on the campus are our internship students who maybe come to visit in order to gain some experience in one of the faculty labs and to build a relationship with the faculty in order to apply later on for their graduate studies with us. And English is the language of instruction. So everybody that you meet at KAUST will speak English. If you wanted to learn Arabic, there are, of course, opportunities to do that in your own time, but it's not necessary to speak Arabic in order to come and be admitted. In fact, you will need to have some proof of your English language if you're not a native speaker. And what's really unique about KAUST is that every student who is admitted comes on a KAUST fellowship, and you don't need to apply separately for this fellowship. If you are successful in gaining admission to KAUST, then you will automatically receive the scholarship. And it's very generous. It includes free tuition, so you don't have any tuition fees to pay whilst you're studying here. And it also includes an annual living allowance, normally between 20 and 30,000 US dollars a year. This varies depending on whether you're an MS or a master's student or a PhD student. Every student also has free housing on the campus, so you won't have to worry about accommodation costs or bills or anything like that. The only exception to that is if you come with your family, then maybe you have to pay a little bit more to upgrade to a larger accommodation that's suitable for your family. And we have on the campus medical facilities. So if you did have an emergency or you needed to speak to a dentist, it's completely covered your healthcare whilst you're here as well. And all students are allocated a relocation advisor. So this means that when you are relocating to KAUST, somebody will be there to help you with the visa process, to make sure that they will book the flights for you. They will help you with the taxis to and from the airport to actually get to the campus here. So you're really very well looked after when you're admitted to the university. And KAUST is a small university, but it's highly specialized. We have around 1,200 students, and the majority of those are PhD students. So the community is around 7,000. It's a relatively small university. So if you're looking to be anonymous in your graduate studies, then this possibly isn't the place for you. It's the kind of campus and environment where you will bump into your faculty, you'll bump into friends around the university, and of course in the community as well. So we're small, but we're highly specialized, and we have 3 academic divisions at the university. The first is the Biological and Environmental Science division, which offers things like bioengineering and bioscience, marine science. And then we have the Physical Science and Engineering division that looks at things like applied physics and chemical science, chemical engineering. And of course, we're here today to talk about the third division, which is the CEMSE division, And we have 4 academic programs associated with the CEMSE division. The first is the Applied Mathematics and Computational Science, and we look at things like stochastic numerics. We have faculty specializing in uncertainty quantification, in simulations, oil exploration, these kind of areas. And then we have the Computer Science program, and Professor Harris is here joining us from the CS program, so he will give you a little bit of insight into his research area in that. But we have faculty who specialize in a range of areas, from computer networks to computer vision, machine learning, AI, bioinformatics. There's lots of different areas. We have around 70 different faculty in the CEMSE division, so I can't go into specific details for all of them, but I will show you where to find the information shortly. We also have Nazek here from the Electrical and Computer Engineering program, and within this program we focus on things like integrated circuits. We have experts working on sensors, control systems, power electronics, again a huge variety there. And the final program that we have is the statistics program, and this is our smallest program, but again the faculty are highly specialized in the areas that they're teaching there. So we have faculty who work on things like big data, data science, time series analysis, spatial temporal statistics, and climate science as well. So I'm pretty much at the end, because I know we don't have a whole lot of time today. So I just want to talk very briefly about the admissions requirements if you were to apply to KAUST. Basically, you need to make sure that you have a background in a relevant field of study. So if you're applying to a master's degree in computer science, it's recommended that you have a background in computer science or an associated field. So if you come from a background in social science or in the arts, it's probably not going to be a good fit to apply to KAUST. We have requirements for a statement of purpose and a CV. The statement of purpose is really about your intent, why you want to study graduate studies, a little bit about your background, and of course the CV is shouldn't be more than 2 pages and should outline your important achievements up to this point. You need to provide university transcripts for all the institutions that you've studied at. So if you are applying for a PhD, then you should provide the transcripts for your bachelor degree and also for your master's degree. And I don't want you too much to focus on the GPA, because the way that different countries work out the GPA is different depending on where you're from. But on average, our students, the minimum requirement is around a 3.5 out of 4. So most of our students are actually achieving much higher than that before they gain admission. But if your GPA is very low, then the faculty will want to understand if you're going to be able to cope with the level of courses that we're offering here at KAUST. And as I mentioned earlier, you need to have some proof of your English language, so a TOEFL or an IELTS, and you also need to have recommendations. Please be careful when you're choosing your recommenders. We have had cases of people choosing friends or relatives to write those. Obviously, we prefer it to be an academic mentor, somebody who can comment on your academic experience. If you have done an internship, a scientific internship somewhere, you may want to use your supervisor for that as well. And finally, if you're applying for the PhD or for the MS PhD, you need to have an approved sponsor. And there are 2 ways that you can do that. The first is that you reach out to the faculty directly and see if they are willing to take you into their group. And maybe we can explain a bit more about that later, since we have faculty online with us. And the other way is that you simply put the names of the faculty in your graduate application, and then when the application is forwarded to them, they will be able to see that you're interested in working in their area. We are interviews based, so we will consider your standard written application as well as interviewing you for a place to gain admission. So I don't want to take up too much time. I can see I've run over a little bit already. So I will take this opportunity to hand over to Harris and Professor Karalambos, and he's from the Cybersecurity program here at KAUST. And Harris, over to you.
Thank you, Rosemary. Let me share my screen. I believe now you can see full presentation.
Yes, we can. Thank you.
Okay, perfect. So I am Harris Costantino. I'm an assistant professor here at KAUST, and I am the primary investigator of the Centurylab, which means Secure Next Generation Resilient Systems Lab. I am a professor in the computer science program, and I'm also affiliated with the electrical and computer engineering program here in the CEMSE division in the computer engineering, mathematical sciences and engineering division here at KAUST. So what does Centurylab, in which areas does Centurylab work? Centurylab works in the areas of Internet of Things, cyber physical systems, renewable energy integration, power grid technologies. And what is our goal? Our goal is to develop secure and resilient systems. So we're working in the areas of cybersecurity, security and cyber resiliency in a way that we not only trying to protect against all these attackers, but we want to make the system resilient against all these possible hacking events. So in order to do that, we are not only trying to find ways to protect, but in order to find ways to protect, first we need to find ways to attack. So we follow this approach in order to attack and defend systems to make them, as our mission, more resilient. And as you can see from the photos here, these are members of the group that come from a diverse background. We have people from US, Saudi Arabia, China, India, Spain, Greece, and Cyprus. So we are an international environment, much like the environment that is here at KAUST. Just to give you an overview and in some layman terms, what does these areas of research mean? Essentially, we work in industrial control systems. So if you look at critical infrastructures like power systems, water desalination plants, chemical industries, all those critical infrastructures underneath, they are driven by industrial control systems. Those systems are processes and controllers that drive the manufacturing, the product handling, the production and the distribution of all these critical infrastructure. So they include supervisory control data acquisition systems using controllers and remote connections in order to sense and actuate on the physical plant, or whether this is a power grid or a chemical process or anything related that can be characterized by physical process. So what we have the physical process. It can be a desalination plant. Okay, and then we have the control loops. We have a controller that gets measurements from the sensors, and then based on those measurements, takes some decision that it instructs some actuators, some physical machines to take some action in order to control these industrial processes. And then we have the operator looking everything in a human-machine interface in order to operate and control those critical devices in these critical systems. However, as we digitize those systems, security becomes very important. And I'm sure you have read in the news, in TV or some newspapers about a cybersecurity incident those days. There are many, and especially as they appear in critical infrastructure, this is very important, right? We have seen many attacks on power grids. There was the recent attack on this Colonial pipeline in the US that they installed ransomware, so they halted the operations of gas pipelines. So the security landscape is today's reality. There are so many incidents in critical infrastructure, and that motivates us to work on the concepts of cybersecurity and cyber resiliency. So what do we do? As I mentioned in the beginning, we follow this approach of red team versus blue team. Security in general, it's not a quantifiable field. We cannot say that the system is 20 or 80% secure. So, and we cannot test everything in a realistic system, right? So the idea of this approach that we do in my research group is we try to understand and extract vulnerabilities from the system as the attacker would do, and then learn from this exercise, implement some defenses, and then test again. And we do this attack and defense strategy in a constant cycle in order to create some realistic test scenarios as it would happen in a realistic environment. And in order to do that, we need the proper testing environment. And that's why in my group, we do a lot of testing with experimental test beds and setups and what we call hardware in the loop. We're not dealing with standard IT environment, information technology environment. We're dealing with operational technology environment. So there is the requirement of proper modeling. We want to simulate the physical process, and we want to have also hardware of the actual industrial device. So we use this approach, which is called hardware in the loop, in which we connect the system in a loop. So we have one or more hardware components that are connected with a host computer that does the simulation. So in this way, we can have cost-effective and reconfigurable testing environments to test all these cybersecurity solutions that we're developing. Some of the available projects at Centurylab involve developing of resilient models for attack detection in cyber-physical systems, real-time simulation that can be used for cybersecurity purposes, regaining trust in IoT, Internet of Things devices that we use in our everyday lives now, integration of renewable energy resources into power systems in a cyber-secure and cyber-resilient way. And we're also recently investigating ransomware in those industrial control systems. Then, besides all the requirements that Rosemary presented before about GPAs, TOEFL or IELTS score, the most required knowledge is to be strongly motivated and have critical thinking based on your observations and your knowledge in your background courses that you're doing. So just to summarize, in Centurylab, we have internships for undergrads. We have fully funded scholarships for master and PhDs, as well as master and PhD students. We have positions for research technicians and research specialists with the requirement of having a bachelor or a master's degree. And of course, postdoc positions, postgraduate research positions. You can find more information in this URL that you can see on this slide. That is also applicable to the QR code that you can see on the right-hand side on the upper level of this presentation. With that, I would like to thank you for your attention. Feel free to contact me and the lab on this email that you can see on the screen, and also visit us on the website of century.kaust.edu.sa. Thank you for your time.
Thank you very much, Harris. That was really interesting. Are you looking for students in your group particularly at the moment?
Yes, I'm looking for internships at the bachelor and master level, as well as students that are interested in working with me for a PhD.
Okay, excellent. So Harris is going to be online for another 5 or 10 minutes. So if you have specific questions to him, please write them in the Q&A box now, and he can answer those as we continue to hear from Nazek, who is a professor of electrical and computer engineering. Thank you, Nazek. I think you need to remove your mute.
Sorry. Okay. Thank you, Rosemary, for the introduction. So can you see my screen?
Yes, we can see that. Thank you.
Okay, great. Okay, so hello, everyone. So I'm Nazek Atab, an assistant professor of electrical and computer engineering here at KAUST, and the principal investigator of the Smart Advanced Memory Devices and Applications Lab, which is for SAMA. So before I talk about our lab's focus of research, I would like to first talk a little bit about my career overview. So I received my bachelor's degree from the Canadian University in Computer and Communications Engineering, And then I received my master's and PhD from the Masdar Institute of Science and Technology under a collaborative program with the MIT and funded by the U.S. Office of Naval Research. During this period, I have received several awards for my research, including the Foreman in Science Fellowship by L'Oréal UNESCO and the International Rising Talents Award, among others. Then in October 2017, I had the honor to join KAUST as a postdoc. And then in 2020, in September, I have worked at KAUST as a research scientist. Also during this period, I have received several awards for my research, including being portrayed among the remarkable women in technology by UNESCO, being selected for the ECS Rising Stars program at UC Berkeley, being selected among the innovators under 35 and MIT Technology Review, among others. And very recently, around 5 months ago, I have joined KAUST as an assistant professor. So although I have been working at KAUST as an assistant professor very recently, but I do have an experience here, and so I know very well the excellent and state-of-the-art facility that is available here. And during this period also, as an assistant professor, I have been appointed as an IEEE Electron Device Society Distinguished Lecturer and as a NEOM change maker. So now I will move to talking about our research focus. So currently we are living in a continuously digitized world where interconnected smart devices interact with the physical world and communicate seamlessly over the internet. This digital transformation is taking place thanks to several exciting technologies such as the Internet of Things, artificial intelligence, augmented reality, among others, which are bringing numerous benefits to our lives through our different fields, from transportation to healthcare to agriculture. And now if we take a closer look at any of these smart devices, we can see that they include several key components. So if we take the example of a smartwatch, an Apple Watch, and we disassemble it, we can see that it includes several key components, which include the communication unit, sensors, memory, processor, and communication units. And as the memory and processor units have improved over time, we can see that additional sensors were being embedded in addition to having better communication, all of which require higher storage capacity and faster communication. And so the continuous progression of memory devices has been a key technology enabler. So what is the role of a memory device? Again, if we think about a smart system, such as a smartphone, a smartwatch, etc., we can see that these devices, they interact with the physical world, and then they capture the data, store it, analyze it, and then send it out to other interconnected devices. So here you can see the storage role of memory devices, right? However, the role of a memory is not really limited to storage of data only. And so if we think about a smart system, which includes sensors, processor, communication unit, a memory device is needed in between these components in order to organize the flow of data, because each of these devices operate with different speeds. And then memory devices are also needed not only to store data, but also codes, which are used by the processor. And finally, we need the memory to store the data with different storage requirements depending on the application. For example, machine learning and image recognition requiring high storage capacity, because the system will be learning from all data to make future decisions. So from this, we can see that future memory devices need to be fast and reliable. They need to be of a high density, low cost, and low power. But what is the current state of the art for memory devices? So current memory devices can be divided into two main categories, non-volatile and volatile, where volatility means that the data will be lost if the power is turned off. But we can see that the NAND flash, for example, which is currently being used in more than 99% of the applications, provide a low cost but with a slow speed. On the other hand, the DRAM provides a much faster speed but at the expense of a higher cost. Therefore, future memory technologies require being able to combine between the benefits of both devices in terms of high speed, low cost, high density of storage. Especially if we think about, for example, artificial intelligence, where the processor needs to access the stored data in real time. And so if there's if the memory device access time is very low, then, for example, an autonomous car could crash into a tree or a person or hit a person. So in order to overcome these limitations, researchers have worked on developing different memory devices using like new operation mechanisms such as magnetic RAM, ferritic RAM, phase change RAM, and resistive RAM. And while these emerging devices are they are faster and lower power than current NAND flash, but they still show several limitations, including being of lower density, expensive, and showing reliability constraints. Therefore, future memory devices, their main challenges remain the same, being able to combine between non-volatility, high speed, high density, low power, and low cost. Therefore, in our group, we are working on developing smart memory devices, which allow us to enhance the speed of memory devices and the smart systems without having to scale the memory device itself. So, to better explain this concept, if we go back to this chart, we can see that the NAND flash, the traditional NAND flash memory device, has been improving in terms of access time, so it's becoming faster by scaling it down. However, this traditional scaling cannot be pursued indefinitely due to physics limitations, and therefore researchers are looking into alternative approaches to achieve faster computations without having to scale down the single memory device. And one such approach is called Mmd Computing, which is a smart memory that can compute. So we are actually combining between the roles of a memory and a logic device. And also, to better understand this concept, if we think of a smart system, which includes a sensor, an analog to digital converter, memory, and processing units, the Mmd Computing approach is based on merging the memory and the processor together to achieve up to 10,000 times faster operations. This has been a key technology enabler for artificial intelligence, machine learning, and deep learning, has been adopted by several industries, and the projected market is of $31 billion by 2026. So in order to complement these efforts, we are working on in-memory sensing. So we are combining between a memory and a sensor, the roles of a memory and a sensor. Again, if we think about this smart system, we can see that even if we have in-memory computing, data still has to go from the sensor through the time-consuming ADC unit to the memory device. And so if we combine between the memory and the sensor into a single device, we would be able to reduce the number of the devices and achieve faster computations. Such a device, we would like to call it as a Munster. And so, for example, a pressure Munster, when exposed to a pressure stimulus, would store the pressure intensity, while a light Munster would store the light intensity. And so such a device would allow for a faster response, lower footprint area, lower power consumption, in addition to being able to integrate on the same silicon chip as the logic devices. As an example, like current traditional imaging sensors, ADCs, and traditional memory devices require hundreds of microseconds to detect data and store it, while using the Munster device, you can achieve this in nanoseconds. And such a device would be able to store single bit as well as multiple bits. And so different bits will be referring to the different intensities of the external stimulus. And so such a device would be complementing the Mmd computing or Mmd processing device to achieve a more compact system with faster and more real-time data analysis. In order to develop such a device, we need to have good knowledge of memory devices, sensors, integration and packaging techniques. But of course, as a master student, you will be learning and developing this knowledge here at KAUST from the courses and the hands-on experience. As a PhD student, having a knowledge of the fabrication techniques would be a strong plus. Also, such a system would be most promising in applications which require real-time data analysis, especially data that is being acquired from sensors, such as Internet of Things, autonomous cars, augmented reality, among others. And these devices will be fabricating them in a clean room facility that we have here at KAUST. So in this lab, we actually wear a clean room gown, as you can see here, because we are fabricating very small devices, and so we do not want particles from our clothes to fall on the device and damage them. And also, so in this project, we'll be working on, in terms of simulation, fabrication and characterization, and then integration into a complete system, and then packaging them. And then another project that is currently ongoing is related to 4D printing. So I'm sure most of you have heard about 3D printing. 4D printing is nothing but 3D printing of smart materials. So a smart material, when it is exposed to an external stimulus, it can change its shape. And so using 4D printing, we actually 3D print a specific structure. And then when we expose it to an external stimulus like heat, humidity, pH, it will change its shape. And so we are using these structures for healthcare, robotics, and energy applications. Okay, so some of the previous projects that we have worked on, I think I'm running out of time, Rosemary.
Yes, yeah, we are running short on time. We still have Maurilio who has a few things to share as well. So.
Sure. So I'm not going to talk about the previous projects. These are complete. But yes, so the main projects that we are working on at the summer lab mainly include smart memory devices and 4D printing. And so please, I'm currently looking for visiting researchers, masters and PhD students. And so if you are interested in these projects, please do not hesitate to reach out. And we also have here the group's website. Thank you for listening. And if you have any questions, I'll be happy to take them.
Thank you so much, Professor. We have a lot of people asking or who are online from electrical and computer engineering. So can I just urge everybody to please ask your questions in the Q&A box so that we can have this communication with Professor Al-Atab while she's online with us. And in the meantime, Maurilio, if you would like to maybe share some of your student experiences so people can have an understanding of what it's like to be a student at KAUST. Thank you.
Yes, sure. Thank you, Rosemary. Let me just share my screen. I have a couple of slides. Okay, guess you can see that.
Yes, we can.
Okay. Yeah, so my name is Maurilio, and I'm a PhD student at the Communication Theory Lab in KAUST, and also a CEMSE student ambassador. And today I would like to quickly give an introduction to the KAUST life as a student. So just a very quick background on myself. I was born in 1994 in Palermo in Sicily, southern Italy, and I lived there almost the entire life. So I studied there also for my bachelor degree in energy engineering and master degree in electrical engineering. And in 2019, I joined the VSRP program, which means Visiting Student Research Project, from March to June. And I exploited it as both internship, academic internship, and master's thesis opportunity. I was actually mentored by Professor Nazek. And after my graduation, I did all the necessary paperwork to start my PhD in August 2019. But I joined the Communication Theory Lab, as I said, so it was a bit of a switch of topic, but both of them were actually quite different from what I studied before, so don't worry about that. And the main reasons why I chose KAUST are the following. So there is a very high quality of work in general, both from my visiting experience and my PhD experience. I can definitely confirm that, but you can find a lot of papers, very highly cited papers, or important conferences and everything, where you see professors and students, postdocs from KAUST. And I can also mention the support I got for my visiting experience by the core labs, for instance. So there is a large number of staff people that help you to train you in some procedures. Some of them are actually a bit dangerous, but they properly train you in order to do your research. And I also liked a lot the environment and community, which was already something I heard from an ex-high school classmate of mine, who introduced me to KAUST, actually. And as Rosemary said, we have 108 nationalities here. Some communities are very active in organizing events and gatherings, just hanging out together. So I can say, for my experience, maybe I speak Italian maybe 20% of the time because there is a lot of Italian friends here. Another, of course, important aspect to consider is the financial support and all the related services like housing, as we already said, a lot of recreation centers that are available for free, such as the gym or the pool or a golf club or a soccer field. Pretty much any sport you can think of is available in KAUST. Maybe just don't ask for snow sports because of obvious reasons. And yeah, as I said, I got a very nice feedback from friends. The one was already here, but also the other people I met during my internship. And I also chose KAUST because of my expectations, because KAUST is a very young university. And of course, it takes time to grow. And although it was already important when I joined the first time, I expected it to improve over the incoming years, so that after my graduation, I could have a good support for looking for other opportunities. And that's actually what is happening. So I'm already looking for internship for my PhD before graduating, and then maybe to continue as a postdoc. And I got a very good feedback from the other institutions. Another important aspect that I would like to mention is that KAUST provides a lot of exciting opportunities to promote your research, not just with the academic channels, but also with other competitions or events, such as, for instance, the Takadam, which is a competition which is organized in order to promote new ideas for startups. So if you have an idea, you want to develop a product, but maybe you don't know how, you can apply to this competition. And if your idea is promising, you can get some funding and some support from specialized employees that train you and mentor you towards this direction. I actually know many people who did that, and they kept working on these startups even after their graduation. And another thing we probably mentioned already is also the natural attractions of Saudi Arabia, of course. One for sure is the Red Sea. If you are into marine science or just diving or snorkeling, this is maybe the best place in the world to do that. But also, of course, there's other opportunities for hiking in the desert. There are mountains not very far from here. So it's, of course, full of academic and, even life opportunities. Just for instance, to bring an example, I'm very passionate about music, and here I got the opportunity to perform several times, performing my music either alone or with other musicians, very talented musicians. And there is also a great KAUST orchestra, which rehearses roughly once a week, and often during the year performs in front of hundreds of people at the auditorium. So it's very exciting. But as I said, it's not just about this. It's pretty much any other activity that you can think of is already available here. and there's people interested and passionate about that. There is people also there are persons that are so passionate that they promote their own courses for free for the community members, such as I recently joined the salsa class, for instance, for free, and I met a lot of new friends there. And if something is not here already, you also have the chance to make it start. And you have a very supportive community that helps you doing that. If I have still some time, I can quickly talk about my research, but just stop me if I run out. So I'm now working on wireless network architectures for future generations of wireless connectivity, and in particular, my projects during my PhD involved aerial networks, such as the ones that leverage drones or other unmanned vehicles. And for instance, we investigated the performances of the network in rural areas or post-disaster environments, and we tried to investigate how the injection of these nodes in the network can improve the overall performance for a typical user. And we already did some publications, technical and magazine papers, especially also this is one of my ideas that I just got during my PhD, but I strongly believe it would have died if I wasn't supported as I did. So the idea is basically to exploit the existing wind turbine infrastructure to mount 5G transceivers or 4G transceivers on it in order to cover the rural communities. And I just got this idea, and thanks to my mentor and my professor, I was able to make a study out of it and publish a paper, and then also present it in competitions such as the IEEE SASTEC poster contest or the Falling Walls Lab at KAUST. And I got very, very good feedback from them. So yeah, I think that's it from my side, but please reach out to me either via email or now. My email, of course, is maurilio.matrashia@kaust.edu.sa. This is the standard format. And you can also find me on the CEMSE website. If you go to it, and you will find a chat icon where you can chat with student ambassadors, and I'm there very happy to help you in whatever you need. Thank you very much, and I'm here for any question.
Thank you very much, Maurilio. Thank you, Rosemary. Thank you, Professor Elatab, and thank you, of course, as well, Professor Harris, although he is no longer in the session. I invite you all to drop your questions in the Q&A box. I see we got several, and actually many of them got to us by chat. So I think I will read those first so we can answer them as well. So a student was asking, he is from Mozambique, and he has an electric engineering degree. He would like to know if he can apply for the KAUST scholarship program.
Yeah, I can take that one. I just want to reiterate that it is free to apply to KAUST, and anybody can submit an application. You don't need to apply separately for the scholarship. You just apply as standard for your graduate application, and if you are successful, you will be awarded the scholarship. So it doesn't matter where you're from, it doesn't matter where you studied, anybody can apply. But I would urge you to look at the admissions requirements to check that you have a good chance before spending your time doing that.
Thank you very much, Rosemary. So we have another kind of technical question. Participant is asking if study gap in their CV matters, as they completed their master's 4 years ago.
Yeah, I think I answered this one directly to the student already, but I would say that you should definitely address it in your personal statement. The faculty and the admissions committee will want to know what you have been doing for the past 4 years. if it's a study gap where you've spent it, doing something valuable, which is related to the masters or the future that you want, then they may well consider that a good thing. But if it's, you have not been really doing anything, no study, and not really involved in the academic community, they may want to understand if you're really going to be ready to come back to graduate studies.
Thank you very much, Rosemary. I don't think we've answered this one. So someone asked, what is the maximum age limit for PhD admissions?
That's a good one. I don't think there is an age limit that I'm aware of, actually. So I think that it's open for anybody to apply. But again, if you've taken a big gap from your undergraduate or your bachelor degree or your master's degree, they may want to understand whether you're ready to come back into sort of higher level courses.
Thank you very much, Rosemary. So we will now go in the Q&A box. So a participant is asking, if I'm from Brazil, how will I be accommodated at the university? Will financial assistance be available automatically?
Yes, if you're successful in gaining admission, then you will get the financial assistance automatically. Every student gets the same scholarship. So if you apply and you're successful, then you will receive the stipend, you will have no tuition fees, you'll have your accommodation costs covered, and also your relocation expenses and healthcare provided.
Thank you very much, Rosemary. Again, another participant is asking, I'm waiting for my bachelor degree to finish. I finished all of my exams and finished my faculty before 2 months, but I didn't receive my diploma yet. So they finished all their exams, but they didn't get the diploma yet. Can they apply for a master degree, or do they have to wait to actually be in the physical possession of the bachelor's to apply?
No, I think there's a lot of confusion about this generally in graduate studies. You don't need to have your final degree in order to submit the application. You do need to have your final certificate when you arrive on the campus to actually prove that you have been awarded the degree. So you can apply now with the transcripts that you have that state which courses you've taken and how you've been performing in those.
Thank you very much, Rosemary. So we have another question. I have an upper credit civil engineering higher national diploma. Is it possible for me to be admitted for electrical engineering, and what am I supposed to do to get admitted?
That's kind of a difficult one for me to answer because I don't work in the admissions office directly anymore, although I used to. So without seeing the application and understanding what the actual certificate is, what the diploma is, and what courses you've taken, I can't really advise on that right now. But what I can say is go onto the admissions website, which I've put in the chat box, and you can see all of the requirements there for admission. And as Harris said, maybe the faculty are looking for some additional things other than just the standard graduate applications. So, I mean, maybe this is a good question for Nazek, if there's something particular that you look for in your graduate students when they're submitting an application. In terms of the process, there are requirements, but there may be something else that you're looking for. Maybe you would like to say something on that.
Yes, sure. So it will, of course, depend on each professor's research focus. So in my case, I would look at the transcript of the student, the courses that they have taken. So if they have the background that I need, that is suitable for my research. In my case, I need a student who has a background in who has taken courses related to microsystems, microelectronic devices. Of course, this is as a master student. As a PhD, I would like a good experience in fabrication or taking courses at least related to fabrication would be a strong plus. Of course, we always look for passionate students as well. And of course, it will depend on each professor's research focus.
Thank you very much, Professor Nazek. So we have one further question, and this is actually one I've seen already, but I think it might be useful for other participants. So somebody's asking if they have a different, grade scale. So if they don't use a GPA, how can they apply for the master's degree? So who should they request the conversion to?
Yes, I'm sorry, I didn't make that very clear in the presentation. I wanted to say that when you submit your graduate application, you'll just put your original grade. So if, for example, you've studied in Romania and your grade is from 1 to 10, you would put your overall grade out of 10 and then provide the transcript to the admissions office. It will be down to the admissions office to see whether or not your overall grade meets our requirements in order to be admitted. But I really don't want students to obsess over the GPA. The GPA is only one part of the graduate application. So please read thoroughly the other components, which also make a difference as to whether you're admitted or not.
Thank you very much, Rosemary. So we actually have another question. A participant is asking if the IELTS exam is compulsory and if they can take it online. So if the online certificate is accepted.
I believe that during the COVID pandemic, they did allow the IELTS to be done online. I would need to get an update from the admissions office about that. So maybe you can email that question directly. I'll put the admissions email address inside the chat box here.
Thank you very much, Rosemary. And also IELTS related. Yeah, sure. Thank you, Maureen.
Just clarify, yeah, because I think Rosemary already said there is a threshold for IELTS, 6.5, I guess, out of 9, right? Yeah, but also TOEFL is an option. Some people might prefer taking the TOEFL. And for someone maybe is not 100% sure about joining, maybe as the person from civil engineering maybe asked if can join electrical engineering. I think there is also it is also a good option to evaluate visiting opportunities before coming for PhD. So maybe we can go through the website and see some professors who propose visiting projects and projects for visiting students, and maybe do few months to understand if that's compatible with them, both the professor and the student actually, and then maybe apply for PhD just to be sure that that's something doable.
Thank you very much, Maurili, for this specification. Thank you. So we don't have any more questions for now, but I encourage you to drop them in the Q&A box as time is about to run out. So I'm sure that everyone here will be happy to help you. And in the meantime, of course, I would like to remind all participants that you will get a recording of this webinar. So if you missed any important information, you will be able to rewatch the webinar at your own pace. So regarding important information, Rosemary, I was wondering if you could maybe go over, deadlines or any other relevant information that students should consider before submitting their application.
Sure. So the next admission deadline that we have is on the 16th of December, and this is for admission in the fall. So we have two admissions intakes. One is in the spring and one is in the fall. The spring is really only for PhD students, and the fall is for all students, masters and PhD. So the majority of our students are coming in the fall. So the next deadline is on the 16th of December. You can apply online, and I would urge everybody to go onto the CEMSE website, and there you will find all of the faculty areas of expertise and their interests. And also you can chat to our current students online there, and Murillo included in that. So if you have any follow-up questions or you want to watch his blog in Italian, you can see that all online. And we have that's it really. Just that the deadline is the 16th, and that's the next admission is in the fall.
Thank you very much. So, of course, we have a question. Unfortunately, the webinar is in English, so we are very sorry about that. We cannot answer in Spanish, but I'm sure if you reach out to admissions@kaust.edu.sa, they will be more than happy to help you. So we have a final question in the Q&A box. Participant is asking, what are the requirements for visiting projects?
We didn't have much of a chance to talk about the internships today, which is a shame because there is really so many opportunities just within the visiting project section. We have, for example, online masterclasses that students can attend in over 2 or 3 days. We have on-campus events which could last anything from a few days up to 6 months. And all of that information is on the Cmc Internships website. So if you go onto the Cmc Internships website, you can see the different projects that are available, including the VSRP, which is the Visiting Student Research Project, where students participate with a faculty member in an academic project for around 6 months. And also our short-term visiting projects as well. We're just opening up now to visiting students to come back onto the campus. And there are some vaccine requirements that's all listed online. So if you do check, if you're interested in internships, you can go on there and find the information that you need.
Thank you very much, Rosemary. So I think we are done with the questions. So if you don't have any more questions, I would take the chance to thank everyone again for joining us tonight. Thank you for connecting. Thank you, Rosemary. Thank you, Nazek. Thank you, Maurilio, for giving us your time and for taking the time to answer the participants' questions. It was my pleasure to moderate this webinar, and I want to remind you that we have more upcoming webinars with KAUST. So if you are interested in knowing more about their academic offer, stay tuned. We will get back at you with the next webinars. So thank you once again for joining us. It was my pleasure to have you here, and I hope to see you again next time for a new webinar with KAUST University. Thank you very much.
Bye.
Thanks, everyone.
Have a nice evening. Bye-bye.
Bye-bye now.